Witness the power that changes our world. Welcome to the El Niño season.
Welcome to your dose of wowness. I want you to imagine standing in the dry grassland of a small British Columbia valley. It's June 29, 2021, and you're in Lytton, a town at the confluence of two rivers, surrounded by ponderosa pines. You might expect a warm summer day, but instead you're experiencing something completely unprecedented.
49.6 degrees Celsius. I mean, that reading in Lytton didn't just break an 80-year-old Canadian national record, it absolutely shattered it. We're not talking about edging past it by a fraction of a degree. It beat the record by a nearly impossible margin of almost 5 degrees. To put that into perspective, that's a gap that usually separates entirely different climate zones.
And then, the very next day, June 30th, the visceral tragedy of that extreme heat became painfully clear. A wildfire, fueled by those bone-dry conditions, just swept right through Lytton. It burned 90% of the town to the ground in a quarter of an hour. The residents literally had just 15 minutes of warning, and tragically, 2 people lost their lives. So what actually caused this? Well, it was an invisible trap built way up in the sky.
The jet stream is the reason weather moves from west to east across the mid-latitudes. It is the reason eastbound transatlantic flights from New York to London are 1 to 2 hours faster than the return trip. It is the reason El Niño's effects on the Walker circulation translate into warmer winters in Canada or wetter winters in California. The ENSO teleconnection runs through the jet stream. Everything the arc is built about tropical ocean temperatures affecting the weather of distant continents operates through this single atmospheric structure. I want to show you what it actually looks like and how it works.
Okay, let's really dive into this explainer. Try to picture a narrow, violent ribbon of vapor rushing 9 to 12 kilometers right above your head. This force was actually first discovered back during World War II. Bomber pilots flying over Japan suddenly found their aircraft held completely stationary mid-flight, just suspended there by its sheer power.
So, the crucial point here is how this whole thing forms. It basically relies on what we call the thermal-wind relationship. You've got this extreme temperature difference between the freezing Arctic and the much warmer equator, right? And that contrast acts like a massive engine. It fuels these intense 300-kilometer-per-hour winds. It creates a boundary, the polar front, and concentrates all that energy into a tight band that literally dictates everything from commercial flight times to our global weather systems.
A Rossby wave is what the jet stream looks like when it is not running straight. It meanders, developing large northward and southward loops that propagate slowly around the hemisphere. The crests of those loops are where heat domes form. The troughs are where cold air spills south. And when a loop stalls, when the normal propagation stops and the pattern locks in place, you get the kind of extreme that breaks records by 5 degrees instead of fractions. The 2021 Pacific Northwest event was a stalled Rossby wave. Understanding why it stalled is the most consequential open question in atmospheric science right now.
So just imagine that incredibly fast river of air buckling into these massive, slow-moving loops. As these waves ripple around the planet, the crests that push northward build up suffocating heat right beneath them. And conversely, the troughs that dip southward, they pull down and dump freezing Arctic air over us.
Returning to Lytton for a second, the mechanics of this trap become pretty clear. What happened was an omega block formed. Think of a deep ridge trapped between 2 troughs, literally shaped like the Greek letter omega. This setup caged a descending mass of air directly over the Pacific Northwest, and it just held it there for 2 weeks. That descending air suppressed any cloud cover, maximizing the solar heating, and basically turned a typical summer high into this ruthless, self-reinforcing heat dome.
Let's look at the brutal math of climate attribution for that exact event. Historically, this specific blocking configuration was a 1-in-1,000-year phenomenon. But transformed by background warming, that exact level of intensity was made at least 150 times more likely. So the jet stream built the trap, for sure, but the background climate loaded the gun with heat.
Now this connects globally, pointing directly back to the tropical oceans. The massive energy shifts of the El Niño Southern Oscillation, or ENSO, well, they don't just stay in the tropics. They launch these invisible atmospheric ripples poleward, fundamentally altering where the jet stream flows.
During El Niño, the jet stream is pushed equatorward, shifting south to drench California in rain and warm up the northern United States. But flip that to La Niña, and that river of wind is pulled poleward, shifting north.
And what that does is allow Atlantic hurricanes to thrive in the tropics without the high-altitude wind shear that would normally just tear them apart.
So, the invisible chain is complete. Tropical ocean anomalies completely dictate local mid-latitude weather by reshaping these colossal atmospheric meanders. Whether you end up getting a quiet summer or a historic flood is literally being decided thousands of miles away, all based on how the ocean flexes this massive river of wind.
The Arctic is warming 3 to 4 times faster than the global average. That differential warming is reducing the temperature difference between the pole and the mid-latitudes. The jet stream is driven by that temperature difference. A smaller difference means a weaker jet stream. A weaker jet stream develops bigger, slower meanders. Bigger, slower meanders mean more persistent blocking events. More persistent blocking events mean longer heat domes in summer and longer cold outbreaks in winter. That is the hypothesis. The debate is over whether the signal is already there in the data. I want to tell you exactly where the scientific community stands.
To put some numbers on it, the Arctic has already warmed by 3 to 4 degrees Celsius. This is largely driven by a pretty vicious ice albedo feedback loop. You see, as highly reflective sea ice melts away, it exposes dark ocean water underneath. That dark water then absorbs way more solar heat, which relentlessly melts even more ice, speeding up the entire warming process.
And this brings us right to the Francis Vavris wavy jet hypothesis. The theory basically outlines that a weaker temperature gradient creates a slower, lazier river of wind. Think about a slow-moving river on land, it naturally starts to meander. The jet stream does the same thing. It becomes highly prone to those massive, stalling loops that lock extreme weather in place.
Now, the scientific tension here is pretty clear. The physics of this hypothesis are completely sound, but honestly, the 40-year satellite record is still just too noisy. Right now, scientists are trying to separate natural jet stream chaos from a definitive forced climate trend. The models definitely support it, but getting that rock-solid observational proof, that's still a very open scientific frontier.
In February 2021, the temperature in parts of central Texas dropped to minus 23 degrees Celsius. The power grid failed. At least 246 people died. The economic damage was approximately $195 billion, the costliest winter weather disaster in U.S. history. The immediate cause was cold Arctic air spilling south through a buckled jet stream. The trigger was a sudden stratospheric warming event that had weakened the polar vortex 6 weeks earlier. Forecasters had predicted increased odds of a cold outbreak from the stratospheric signal. What they could not fully anticipate was Texas.
This entire disaster actually unfolded over a period of 6 weeks. It kicked off in early January with a sudden warming event way high up in the stratosphere. Over the following weeks, that signal progressively descended, violently buckling the tropospheric jet stream, and that eventually dumped a massive reservoir of freezing Arctic air deep into the American South by mid-February.
Let's ground this atmospheric anomaly in its catastrophic human and economic cost. $195 billion. 246 lives lost as critical grid infrastructure completely failed under conditions it was just never designed to handle. It's a stark reminder that extreme jet stream loops bring deadly ruin in both directions. It's not just about extreme heat, but also profound, inescapable cold.
And this lethal global pattern, it simply keeps repeating. Just look at Europe. Stalled Rossby waves created massive blocking highs that trapped stagnant air over France, Spain, and the UK, tragically killing tens of thousands of people in 2019 and then again in 2022. I mean, the UK broke 40 degrees Celsius for the first time in recorded history.
So, there is one absolutely vital point to remember here. Even if the jet stream's wobbles aren't definitively worsening just yet, the air trapped inside these atmospheric cages is inherently hotter than anything in human history. The cage itself doesn't even have to change size to become significantly more dangerous. Here is what the jet stream tells us, as the fourth piece of the arc's mechanistic picture. The atmosphere is not a collection of independent systems. The Walker circulation in the tropics drives Rossby waves into the jet stream. The jet stream delivers those waves as weather to the mid-latitudes. The Arctic warming that is shrinking the temperature gradient weakens the jet and may be making its meanders slower and larger. And all of it, the tropical Pacific, the mid-latitude circulation, the Arctic boundary, is now operating within a background climate that is warmer than at any point in the past 120,000 years. The cage the jet stream builds has always been there. The heat it can trap has never been this high. Tomorrow, day 100, the milestone explainer. Everything this arc has built, the Walker circulation, the 1877 famine, La Niña's floods, the jet stream's wobble, comes together in the question that the science is now actively trying to answer. Is climate change making El Niño stronger,
making La Niña more persistent, making the jet stream wavier, and what does the most honest reading of the current evidence actually say? Day 100. See you there.